Yes, another ball Earth pseudoscience myth has bitten the dust. This is a follow-up to my last video where I show that it's a myth that we could have gas pressure next to this so-called vacuum of space. Okay, so now in this video I want to point out that the fact that we can observe a pressure gradient in our atmosphere proves that our container is small, because the gradient is within our observation. So do we even need a container for gas pressure? Well, let's see what it says. The pressure of a gas is the force that the gas exerts on the walls of its container. So yeah, we need a container for gas pressure. So a lot will say, well, yeah, but we have gradient pressure. Well, the optimum word being pressure. Gradient pressure is still gas pressure and still requires a container. Because if our atmosphere were actually exposed to the vacuum of space, right, as vast as they say space is, our Earth combined with space would essentially become its container, one container, right? And as gas pressure will do, it will fill the empty space. So just like I'm going to show you in this diagram here, all of our atmosphere would be gone because it would fill the space and we would no longer observe any gradient. Okay, so here I am on the Earth, and here's our atmosphere. You can clearly see that we have atmospheric pressure, we have a gradient, it's thicker at the bottom than it is on the top, and even though gas pressure will fill the space of its container, we also have a relative density at play, right? So the denser molecules will form at the bottom and the lighter ones on the top. And being that it's a small container with a relatively low ceiling, we can observe our atmospheric pressure gradient. And this proves that it's a small container. So I'm going to stretch this dome up, okay? I'm stretching the dome. Now, as I stretch the dome, I'm creating a vacuum, a bigger vacuum, right? The same amount of air molecules inside, but the container is getting bigger, right? And as the container gets bigger, we stop being able to see the gradient, because relative to our size on Earth, the gradient is too big. Any gradient that exists, as you make the container bigger and bigger, we can't observe a gradient. But the fact that we do observe a gradient means our container is small. So that's what I'm showing here. Molecules are spreading out. They're spreading out. They're spreading out because the container, I'm stretching the container up higher and higher. There goes p-brane. He's going down. He can't breathe anymore. He's on the ground, and there's the Earth right there as a desolate nothing, because all the atmosphere and the water would be gone too, just like I showed with this. When I use this turkey baster, right? Now when I squeeze the plunger or the ball of the turkey baster, I'm forcing the air out, right? Now the turkey baster ball is resilient and will bounce back, right? It'll bounce right back to its shape. You let go of it and it bounces back. Now as it bounces back, the vacuum is created because the space is now bigger than the molecules inside. And molecules will rush inside, right, and fill it up, just like these tankers, right? They sucked all the air out of the tankers, and nature abhors a vacuum. So the air molecules are trying to rush in, and they're trying to go through the container walls. You know, this is why NASA has some kind of facility, a vacuum chamber, and the walls are 6 to 8 feet thick, all right, because they don't want this happening to their little facility, right, as they suck all the air out. So I'm creating a very slight vacuum with this, and sucking the water in, no problem. Sucking the air in, no problem. In and out, air goes in instantaneously. The water, a little bit heavier, right, goes right up. So the atmosphere, again, would not last next to the vacuum of space. Now you might say, but gravity. Well, where do you think I'm doing this little experiment right now? I am on the gravity ball as we speak, doing this experiment. And I am sucking water up with a very slight vacuum, probably not as strong as the vacuum of space, right? And the water is coming up. So not only would we have no air, we have no water. It's done. This proves the fact that we can observe gradient pressure within our observable atmosphere proves that the container that holds our atmosphere, whether it be a dome or whatever, is small. Thank you so much. I have some t-shirts. Here's some couple awesome new prints. If you don't want to wear a flat earth t-shirt, because you know that's highly provocative and can set people off, wear a p-brane t-shirt. Besides, these logos that I'm coming up with are super cool. And check them out. Thank you so much. Bye-bye.